If you are someone who already does input validation by default when you write code, you're on the right trajectory to become a software developer. If you choose to become one, you will have colleagues who would be software testers. Their full-time job is to just break your code. Let us look at this program where you're expected to take the input for two numbers and display the result of dividing the first number with the second one. This seemingly unsuspecting code will crash during runtime when the second number entered is a 0. If you take a look at this lengthy traceback error message, you would see the specific exception that has occurred is a 0 division error. An exception is an error that occurs while a program is running, causing the program to abruptly halt. To make sure this error does not occur, you can just write an if-else block. Easy fix, right? Now you might think you wrote a program that would never crash. Let's see what happens when the user enters the numbers as strings. There you go. The program crashed again, and this time the exception raised is value error. The same thing happens when the user enters without entering any value. Basically, that's going to be an empty string. To handle the exceptions, programming languages have what is called an exception handler. An exception handler in Python starts with keyword try. The lines of code for which exceptions might occur will be inside the scope of try block. We can formally call all these lines as try suite. The try suite is followed by an exception clause, typically contains the exception name as well. This would make sure that the exceptions are caught during the runtime gracefully. Instead of the red font Python error messages, your program gracefully displays the customized error statement you wrote in the except block. If the code in try suite runs without raising any exceptions, the code you have written in except block does not get executed. We should reserve the use of exceptions for issues that cannot be handled by logic in the code, such as while loops or if statements. Exceptions should be used for errors that we would have no way to detect or prevent in any other way. Let me demonstrate exception handlers using this program. The try suite consists of several lines of code that can generate a wide range of exceptions. If an exception occurs, the program will run code in the except suite that has an except clause with the matching exception name. If there is no except clause with a matching exception name, then the except clause with no exception name will run. Let us start with this line. If the file is not present in the specified location, and because we are opening it in read mode, it is going to throw input-output error exception. If either first or second line in the file is non-numeric, it is going to throw value error exception. And for all the other errors not explicitly listed in the except suite, the generic except clause will get executed. In here, that will happen when the denominator is a 0 and a 0 division error is not explicitly handled. If you like to display an exception's default error message, you can do it this way. Let us try to see this in action using this program example. If IO error occurs, this default message is displayed. If value error occurs, this default message is displayed. All right, let's look at few optional features of exception handlers in Python. You can optionally use else after try and except block. The code in else block is executed only if no exceptions are raised in try suite. The code within finally block is executed irrespective of whether the exceptions are raised or not. The usage of else and finally is optional. You can use it wherever you deem that to be necessary. As I pointed out before about how important it is to close the connections to the file, I would write the file connection closing code in finally block such that it gets executed no matter what. I hope these features gave you a glimpse of what software developers do.